Hello, this is Mrs. Ward, and I'm going over the review worksheet for section 7.5 and 7.8. So the first ones are asking you to find the inverse without doing a calculator. If they give me a 2 by 2, I'm going to choose to use the determinant formula. So I'm going to find the determinant first. So negative 3 times negative 11 will be a positive 33, minus, and then 6 times negative 5. Negative 6 times negative 5 will be a positive 30. And that'll just be 3. To find the inverse, I take the reciprocal of that determinant. The 11 and the 3 change places. The 5 and the 6 stay in the same spot, but their signs change. Distributing the 1/3, I'm going to have negative 11 thirds, positive 5 thirds, 2, and negative 1, and that's my inverse. To do the next one, I'm going to have 12 minus 6 times 2 is also 12, and I'm going to get 0. When I go to do the inverse, I'm going to do 1 over 0. Well, this is undefined, which means it's not invertible. In other words, I cannot find the inverse of that matrix C. If I was trying to do it by the augmented matrix, when I went to do the one in row 1 and row 2 to eliminate the x, I would have ended up with 2 zeros here, whatever those are. And once I have the 2 zeros, I know it's not invertible. The next one, trying to find the inverse. So to do this, I'm going to write the augmented matrix next to it. Well, the identity matrix in an augmented form. So now I'm going to follow the pattern. I'm going to do row 1 and row 2 to eliminate my x. So I'm probably going to multiply. I'm going to leave row 1 alone. And I'm going to multiply row 2 by a negative 2. So that'll be a positive 2, negative 8, negative 2. And when I add, I get 0, negative 3, negative 4, 1, negative 2, and 0. And I do row 1 and row 3 to eliminate the x. Well, that's already a 0, so I'm just going to copy that row down. Now, the next thing I'm going to do is I'm going to look at row 2 and row 3 to eliminate the y, and I am going to choose to multiply. I'll multiply row 1 by a positive 4. 4 times row 1. I'm sorry, row 2. So this will be 0, negative 12, negative 16, 4, negative 8, 0. And then row 3, I'm multiplying by a 3. And when I do that, I get 0, 0, negative 1, 4, negative 8, 3. Well, I want this to be a positive 1, so I am going to take the time right here, right now, to divide everything by negative 1. And I'm going to get negative 4, 8, and negative 3. At this point, what I might want to do is pick up my calculator and do the inverse on my calculator and make sure that the last row of the inverse is this negative 4, 8, negative 3. And if it is, that means I'm on the right track and I'm going to keep on going. If it's not, that means somewhere along here I made a mistake. And I only have two operations to check. So it's a lot easier to find a mistake in 2 things instead of 6 things. So I've done that. Now I'm still going on. So according to the pattern, I am going to do row 3 and row 2 to eliminate the z. I know there's not a z. Well, I know there's not a z, but we're going to call it z. And so what I am going to do is I am going to multiply row 3. I said row 3. I'm going to multiply row 3 by a 4. So that's going to be 4, negative 16, 32, and negative 12. Row 2, I'm copying down. And when I add, I get 0, negative 3, 0, negative 15, positive 30, negative 12. Since I just have one number over here, zeros everywhere else, I'm going to choose to make that a 1. I'm going to divide everything by negative 3. So it'll be 0, 1, 0, positive 5, negative 10, positive 4. Now, if I did my inverse on my calculator, I'm going to check and make sure my second row is right. If not, I'm going to go back and check what I just did and see if I made a mistake. And now at this point, row 1 has not changed at all. And now I'm going to work on row 1. And it doesn't matter the order that you do these in, but according to the sheet, it says that I am going to do row 3 and row 1 to eliminate the z. So I'm going to choose to multiply row 3 by a negative 4. So 0, 0, negative 4, positive 16, negative 32, positive 12. And row 1 is negative 2, negative 3, positive 4, and 1, 0, 0. And when I add, I get negative 2, negative 3, 0, 17, negative 32, and 12. Then I'm going to look at this is my row 1, and I'm going to ask myself, what do I have to multiply row 1 by and row 2 to eliminate that y? And I'm going to choose to multiply by a 3. So I'm going to just write that here. 3 times row 2. So this will be 0, 3, 0, 15, negative 30. Ooh. Negative 30. I'm sorry, got distracted. Negative 30 and 12. So I'm going to have negative 2, 0, 0. When I add these two, I get 32, negative 62, and 24. Those are some big numbers. Now I just have one digit. I am going to divide by negative 2. And when I do that, I get 1, 0, 0. That'll be 16. Oh, negative 2, negative 16, positive 31, negative 12. So when I write this, so what should happen is on the left side, you have the identity matrix. That's how you know you're done. And note that these are all positive ones. And then over here is my inverse. And to check it, I can go way back up here. And if I would have raised this to the negative 1 power, just this matrix to the negative 1 power, I should get this is my inverse. And that's how I would check it on my calculator. But you have to show all the work. Okay, doing the next one, it says find the determinant. These should be done without a calculator. So we just did this number 2. I'm just doing 8 minus and negative 5. So that's going to be 13. And that's it. I stop. It just wants the determinant. That's all I have to do. To find the determinant of a 3 by 3, I'm going to copy down the first 2 columns. Then I'm going to do my loops in the right direction, hopefully. So this, this, and this. And when I do that, I'm going to have 0 plus 8 plus 2060 minus, do my loops in the other direction. And I'm going to have negative 12 plus 8 plus 0. So this is going to be 68 minus, this would be negative 4. So this will be minus negative 4. So plus 4. And I get an answer of 72. Again, I can check both of these answers on my calculator to make sure I got them right. Number 3, multiply. These should be done without your calculator. So here I have a 2 by 3, and I'm multiplying it by 3 by 2. It can be done because those two numbers match, and my answer is going to be a 2 by 2. So let's start. Row 1 times column 1. If you want to highlight, you can highlight. I'm not going to highlight the whole time. I'm taking row 1 times column 1. So when I do that, I'm going to have negative 6 times negative 5 plus negative 2 times negative 5 plus 6 times negative 3. So it's going to be 30 plus 10, so 40 minus 18. And I'm going to get 22. Now I'm going to do row 1. I'm going to multiply it by column 2. So I'm going to take negative 6 times positive 3 plus negative 2 times negative 5 plus 6 times 0. And I'm going to have negative 18 plus 10, so that's going to be a negative 8. Row 1 has been multiplied by both columns, so now I'm going to go down to row 2 and just start with column 1. So I'm going to have 3 times negative 5 plus 1 times negative 5 plus negative 6 times negative 3, and that's going to be negative 15 minus 5 plus 18, and that's going to be negative 2. And then finally, row 2, column 2 will be 3 times 3 plus 1 times negative 5 plus negative 6 times 0. And so I'm going to have 9 plus negative 5, which will be positive 4. So I am going to put them in the matrix and put the elements in the correct spot. So there I go. Next one, I have I have a 4 by 2, and I'm multiplying it by 2 by 2, so it can be done. And my answer is going to be a 4 by 2. So here we go. Row 1 times column 1 will be negative 5 times negative 6 plus 6 times 3, so it's 30 plus 18, which will be 48. Row 1 times column 2 will be negative 5 times 0 plus 6 times negative 5, so that's going to be a negative 30. Now row 1 has been multiplied by both columns, so I'm going to move down to row 2, column 1. So this is 0 times negative 6 plus negative 1 times 3, and I'm going to get an answer of negative 3. Row 2 times column 2 will be 0 times 0 plus negative 1 times negative 5, so that's 0 plus 5, and that'll be 5. I'm going to go over here so I can still see my matrices. I'm going to do row 2 has been multiplied by everything, so now row 3 times column 1 will be 5 times negative 6 plus negative 4 times 3, so that's negative 30 plus a negative 12, that'll be negative 42. Row 3, column 2 will be 5 times 0 plus negative 4 times negative 5. So 0 plus 20 will be 20. Row 4 times column 1 will be negative 5 times negative 6 plus negative 1 times 3. So that's 30 minus 3, positive 27. Whoopsie, positive 27. And then finally, row 4 times column 2. That's going to be negative 5 times 0 plus negative 1 times negative 5, and that'll just be 5. So my matrix, and this is like row 1, column 1, 4, negative 30, negative 3, 5, negative 42, 20, 27, and 5. And there's my 4 by 2. Okay, now going on, you can use your calculator. So this one is solved by Kramer's rule. So Kramer's rule says I take the determinant of the coefficient. So you can do this in your calculator. You can do it by hand. And I did these on my calculator, and I got negative 26. Then to find the x, and this is what you have to show me. You have to show me the determinant of the coefficients. Then to find the x, I'm putting the answers in the x column, leaving the y column alone, and I'm going to divide that answer by negative 26. So when I do this determinant, I get negative 52, dividing it by that negative 26, and my final answer is a positive 2. To find my y, I'm going back up to my coefficients. The x's stay the same. Now the y gets the answers, still dividing by that negative 26. And when I do that, I get 78 divided by negative 26, and my answer is going to be negative 3. So this answer is 2, negative 3. Now to do the next one, I've got to write this down here. To do the next one, I'm going to do the coefficients. So negative 3, negative 4, and that's understood to be a 0. Negative 1, 2, 3. 1, negative 1, 3. And when I find the determinant of that, I'm going to get negative 51. All these determinants are being done on your calculator. Okay, so the x column, everything else stays the same. And I'm going to divide it by negative 51. So when I do this one, I get 51 divided by negative 51, and my final answer for x is negative 1. To find y, going back up to my coefficients, and then if I want to switch colors to emphasize what I'm doing, the x column will now get my answers, and then I will go back and do the same. I don't remember what color I was. And I'm still dividing by that negative 51. When I do this, I get a negative 153 over negative 51, and that ends up being 3. And lastly, to find the z, I'm going back up here. The x and the y column will stay the same. Now the answers are going to go in the z column, so 4, 6, 21. And I'm going to divide this by negative 51. And when I do the determinant of this matrix C, and that should just be a straight line, I get negative 204 divided by negative 51, and my answer is a positive 4. So that ordered triplet will be negative 1, 3, and 4. Okay, the next one says solve the system by using the inverse matrix C. So I'm going back to that coefficients. Times that x, y, and z is equal to my answers, which are 9, negative 11, and 16. So to solve this for my x, y, and z, I'm going to take my coefficients, raise it to the negative 1 power on my calculator, and multiply it by my answers. And I'm actually going to do that for you, so hold on. So I have my calculator out. I'm going to hit the 3 by 3 matrix. I'm going to type in those coefficients that I just had, which were negative 1, 1, 2, oh, negative 2. I'm going to get out of that matrix. Well, let me go up and grab that matrix. Then I'm going to hit times. And now I'm going to multiply it by the answers. So I'm going to go to the matrix C. I'm going to grab that 3 by 3. I still have 3 rows, but now I only have 1 column. And I'm going to type in those answers. And when I hit enter, negative 30, 83, and 69 is not correct. You know, I thought about editing this out, and I thought, no, better not. This is a great learning. I got the wrong answer, and I knew I got the wrong answer, but, and if I would have put it in, I would have checked it and known that I got the wrong answer, but I forgot to take the inverse of this. I forgot to raise this one, the coefficients to the negative 1. So if I do that, now I get the right answers, which are -2, -1, and -3. So all three are negative. Whoopsie, wrong no sheet. Okay, write the system of equations in 3 variables that can be used for the following, then solve the system. The movie theater charges $12 for adults, $10 for senior citizens, and $8 for children. 12 movies are children under 12 movies on Sunday afternoon. This past Sunday, they had a revenue of $1,972 for 183 tickets sold. There were 16 more seniors than children. How many children attended? So let's say I let A equal adults, S equal seniors, and C equal children. And that's going to be the number of adults, number of seniors, number of children. So I see that I had 183 tickets sold. So I know that adult tickets plus the senior tickets plus the children tickets equal to 183. Now for each adult ticket, I got $12. For each senior ticket, I got $10. And for each child ticket, I got $8. So if I multiply those by the number of adults, number of seniors, and number of children, and add those together, I should get that total revenue of $1,972. Then they tell me that there are 16 more seniors than children. So if I take the number of seniors and subtract the number of children, I should get 16. Now I get to solve this any way I want. If I can use my calculator, I'm going to use my calculator. So let's say I do my coefficients, which are 1, 1, 1, 12, 10, 8, and then 0, 1, -1. Let's say I raise that to the -1 power and multiply that by my answers, which are 183, 1972, and 16. I should get the correct answer. So I'm going to go over here and do that. Now, if I had to do it by hand, I would probably take row 1 and row 2 and eliminate my A, and then this one I already have my A eliminated. But I don't have to do it by hand, so I'm not going to even think about it. So now I'm going to do a 3 by 3 matrix. So that's going to be okay. And then my coefficients are 12, no, are 1, 1, and 1, 12, 10, and 8, and then 0, 1, and -1. I'm going to raise this to the -1 power. And I'm going to multiply that by my answers, which are going to be a 3 by 1. And those answers were 183, 1972, and 16. And when I do that, I get 103, 48, 32. So 103, 48, 32. So this, remember, this is adult, senior, and children. So up here it says how many children attended. I only need this. So my final answer is that 32 children attended. If it would have asked me for seniors, that would have been 48, and then there were 103 adults. But this question is just asking how many children. Next one, write an augmented matrix corresponding to the systems of equations. So let's do that first. So 4, -4, -3, -12, 2, 2, 2, 10, X is 1, Y is 3, there is no Z. And then use your calculator to solve. Well, if I already have this augmented matrix written, I'm probably going to choose to do reduced row echelon form. And remember, it's telling me to use my calculator, so I am going to use my calculator. But since I already wrote it as an augmented matrix, I'm going to use that form. So pulling up my calculator, I'm going to hit Menu, number 7, remember reduced row echelon form, doing my matrices, and remember I'm going to put in this matrices that I see right here, exactly the way I see it. So this is a 3 by 4. So I'm going to tell my calculator that I need a 3 by 4. And then I'm going to type in exactly what I see. So I see a 4. And the calculator cannot have those 3 dots, so I'm not going to worry about it. And when I hit enter, what should happen is I am going to, so I copy my display over. When I do reduce row echelon form on my calculator, the first 3 columns should be that identity matrix. That last column is going to be your answers. So that means that X is equal to 1, Y is equal to 4, Z is equal to 0. So my order triplet would be 1, 4, and 0. Again, you could have done this in multiple ways. You could have done the coefficients, raised it to -1, multiplied it by the answers. No matter how you do it, you're going to get the same answer. Now, number 8 says choose any method to solve the systems of linear equations for x, y, and z and w. So I can do reduced row echelon form just like I did, or I can raise it to the -1 power. Let's do reduced row echelon form. So I'm writing the teacher a note letting them know I'm doing reduced row echelon form. 2, 1, -1, 2, x, y, no z, w. And that 0 will get you every single time. Make sure you know that these are your x's, these are your y's, even though they're not like right up and down. Your Z is missing a Z, so make sure you fill in with a 0, and then your W. I'm putting this in my calculator. New matrix, reduce row echelon form. Loading my matrix. This time it's a 4 by 5. And I'm typing in the numbers as I see them. And when I do that, this is what I get. When I did on my calculator doing reduced row echelon form, this became the identity. See how you have that diagonal of zeros, everything else has a 1. And then this final column here are my answers. If you chose to do it a different way, like I could have done the inverse, so I took the coefficients here, multiplied it by -1 times the answers, you will notice that the answers are the same. And they should be the same because it doesn't matter how you solve it, still get the same answers. So those answers are the same. So 1, 0, 4, and -2. Up to you how you solve it. You just have to give us some type of notation as to how you're solving it. So on your piece of paper, you're either writing the augmented matrix with RREF, reduced row echelon form, or you're showing us that you took the coefficients raised to -1 times the answers to get your answers. But that is a one that's on your calculator, no hand crunching necessary. Number 9 is our way of checking that you know how to do a determinant of a 3 by 3 by hand because I have these X's in here. So I am going to write these first. I'm going to copy the problem down first and then copy down the first 2 columns. So here's me copying down the problem. And then I am going to copy the first 2 columns, so that x minus 5, -1. and then I am going to highlight, loop, whatever, these guys. And when I do that, I'm going to get 0 plus 0 plus, and then this is a -3 times a -3, which will be a +3. But it's 3 times that x minus 5. So I'm going to have a parenthesis within a parenthesis. So when I do this, I have 3 negatives, so it's going to be -15, then 0, 0. And this is equal to 9. I got the equal to 9 from up here. So I am going to have, distributing this 3x minus 15 minus -15 is equal to 9. So this will be plus a +15. So those are equal to 0. So I have 3x is equal to 9. Divide both sides by 3. X is equal to 3. And a great quick way to check it is put 3 back in here. So you would do a determinant of a 3, 1, -3. And if I put a 3 in here, this would be -2, -5, 0, -1, -1, 0. And then when I do that on my calculator, I should get an answer of 9. Number 10, use determinants to find the area of the triangle. So remember, I do that plus or minus 1/2. I'm going to choose positive or negative, whatever I need to do to make it positive. I'm putting in my ordered pairs. So here's my x's, here's my y's, and then here's my column of ones. Put that in my calculator, and I did that. And when I do that, I get -40. So 1/2 of 40 is 20. I want to make it positive, so I'm going to say 20 square units. And that's all I have to do for that. And then the last one, it wants you to use the determinants to find the area of a 4-sided figure. So we'll give you graph paper. I strongly suggest you graph it. So there's -1, 1, 4, 5, 3, 2, 3, -2, and then 6. So here's my 4-sided figure. And what I'm going to do to find the area is I'm going to separate it into 2 different triangles. So I just decided to do it like this. Doesn't matter if you do it the other way, but you're going to have different work. So this point here is -1, 1. This point here is 4, 5. And this is 6, 2. And finally, this is 3, -2. So doing the top triangle, which I'm just going to call 1, I'm going to say plus or minus 1/2. Those ordered pairs are going to be -1, 1, 4, 5, and then 6, 2, column of ones. So when I did the determinant of that, I got -23. So half of that would be 11.5. Remember, whatever I need to do to make it positive. Then when I do the determinant of this one, I'm going to have -1, 1, 3, 2, well, 3, -2, and then 6, 2, my column of ones. So plus or minus 1/2. This time I got a positive 25. So I'm going to take half of that and get 12.5. And when I add those, I get 24 square units. You must multiply the 1/2, make it positive, multiply it by the 1/2 before you add them together. That is a must. You must do that. So here's triangle. This is the area for 1. This is the area for 2. The area of the whole 4-sided figure